Hi friends. Today in our ASUS Solution Architect series, today we are going to cover gathering non-functional requirements for Microsoft Azure. Let us discuss about what are non-functional requirements. Solution architect usually they will design the system, they will design the software. When they design the software, when they design the system, when they design the solution for cloud, we can classify the requirement into two categories. The requirements are usually divided into two types: functional requirement FS and non-functional requirement. What is functional requirement? As a solution architect, when we design the software systems or when we design the cloud infrastructure, this functional requirement define what the system must do, what the software application will do, what the web app will do, what the cloud infrastructure will be used for. So this functional requirement describe the specific action. For example, if you take then any e-commerce website like Flipkart or Amazon, this functional requirement will define the specific action, what it contains. The e-commerce platform will contain a login module, product module, price module, cart, and several other modules. Its behavior or function of the system. So the functional requirement will describe the overall aspect of the software or solution. For example, the functional requirement is the system must allow a user to reset the password. It is one functional requirement. Another one is whenever the user or customer places an order, the system should send a email notification and SMS notification to the customer. It is a functional requirement. So functional requirement means how it is acting, how it is functioning, how it is behaving to the customers. Non-functional requirement NFR. This non-functional requirement they will define how well the system is performs those function. For example, if you deploy any web service, you will configure the web apps and hand over to the respective team. If the application is performing well, fine. If there is any bugs in the application or if there is any new feature need to be added, that is functional requirement. If there is any in the server part, if the server is performing very slow or if it is hanging, that is a non-functional requirement. So how the system is performing, this non-functional requirement they will describe the criteria that can be used to judge the operation of a system, focusing on its quality attributes, constraint and characteristics. So the non-functional requirement is the password reset must send to the user within 5 seconds. Reset the password, reset the customer password is a functional requirement. Reset the password, send it to the user within 5 minutes is a non-functional requirement. In simple term, we can define functional requirements define the features. The non-functional requirement define the quality of the features. So we can often call the non-functional requirement quality attributes or informally the utilities, scalability, reliability, maintainability, usability. These are all non-functional requirement. Let us discuss the category of non-functional requirement. Quality attributes. NFRs are typically grouped into categories that are critical for an architect to consider. As a solution architect, we need to categorize the NFRs. So these NFRs are directly aligned with the Azure Well Architect framework. If you look at the NFR categories, there are performance, scalability, reliability, security. If you look at the performance, it will define the speed and responsiveness of the system under a particular workload. How the server is performing, how the cloud app is performing. For example, if it is a e-commerce app like Amazon and Flipkart, whenever the customer opens the web page, how quickly it is opening. If it is taking some time to load all the images and completed load completed, or when your customer is log into the Amazon portal, whether it is taking lot of time to complete the login process, that is performance of the system. So we can measure the performance based on the latency. Must be a less than 200 millisecond or greater than or less than $90 of all the API costs. How much it will cost? How it is performing? How the server is performing? How the cloud apps is performing? How the Amazon portal is performing? Scalability. The system ability to handle an increased overload or use based by growing resources. For example, the Amazon website, the number of users log into the Amazon portal during the normal days maybe around like 1 or 2 lakhs. During the festival season, the number of users accessing the Amazon site will be around 10 lakh or 1 crore, something like that. So whenever there is an increase in workload, or whenever there is a lot of people using the apps, we need to identify how it is handle the workload. So the system must be able to support 10,000 concurrent users without performance degradation. That is scalability. So we have to design the scalability to accommodate 10,000 concurrent users without performance degradation. So these are all non-functional requirement: performance, scalability, reliability and availability. Reliability means the system should perform its function consistently and maintain continuous operation. How the prod service running? The prod service running 24 by 7 on the all days. How the web app, how the Amazon app is working, whether it is working fine for all the days consistently. That is reliability. So the system must achieve a monthly SLA of 99.99, 4 nines. That is less than 4.38 minutes of unplanned downtime. So this reliability is a non-functional requirement. How to improve the reliability? How to improve the scalability? How to improve the performance? We have to, when we are designing the cloud infrastructure, we have to consider all these NFRs, security, designing, deploying the cloud infrastructure, not only complete the process. We have to secure the cloud infrastructures. We have to protect the system and data from unauthorized access, attacks and breaches, data breaches. So these are all non-functional requirement. All sensitive user data must be encrypted at rest using AES 256 encryption algorithm. So whenever we design a solution for cloud infrastructures. As a solution architect, you need to consider the all these NFRs, non-functional requirement, performance, scalability, reliability, availability, and security. Another NFR is maintainability, the ease with which the system can be updated, repaired, and notified. For example, if the e-commerce site Amazon is running on hundreds of servers, can we go and reboot all the servers at a time? Can we go patch all the servers at a time? If 10 servers are down, hanging, can we replace the servers immediately? How fast we can remove this bottlenecks? How long we can take to make the system functional? So the critical bugs must be a mean time to recover. MTTR is less than 1 hour. That is maintainability. We should have a backup server. The server is down. We should have a backup server. We have to bring it up immediately. Usability. The ease with each user can learn and operate the system. A first time user must be able to complete the onboarding process in under 3 minutes. And compliance. So when we are designing the solution for cloud infrastructure, we have to make sure the compliance standards should be implemented and all the complaints are satisfied. The system must adhere to GDPR data redundancy. So when we are designing the solution for cloud infrastructures, we need to take care of this NFRs and cost. Cost is the major factor. It is a constraint on the capital and operational expenditure. The overall operational cost of a solution does not exceed 5,000 per month. In planning the solution for Azure cloud infrastructures, cost play a major part. Once the budget or cost part for the project is defined and allocated, then only we are going to gather the information about functional requirement and non-functional requirement. How much will be allocated to functional requirement? How much will be allocated to non-functional requirement? Let us see why this NFR drive the architecture. As an Azure solution architect, NFRs are the single biggest factor in making the technology and design choices. Let us consider the first NFR is reliability and availability. The reliability requires the cloud apps and servers should be available for 4 nines, 99.99. That is SLA. What is the architectural impact? You cannot use a single VM. You must use a availability zone and redundant services like Azure SQL database with the geo-replication or Azure Cosmos DB. So if you want to build a reliable system, if you want to build a reliable cloud solution, we need to make sure this reliability and availability non-functional requirements should be considered. The another one is performance scalability and high throughput, low latency. When we are designing the solution for cloud infrastructures, we should make sure the performance scalability should be up to the mark. You must use the scalable resource services like Azure Application Gateway with auto scaling. This is a highly optimized database like Azure Cache Redis for caching or move from monolithic VMs to Azure Kubernetes services for horizontal scaling. So these are all the architectural impact. So another NFR is non-functional requirement is security. We need to make sure our cloud infrastructure should be secure and compliant. So we need to implement Azure Private Link for all the database access and enforce the Azure policy for configuration to avoid deploying high-end VMs or unapproved apps. So we can implement Azure policy to control during the environment provisioning, and we can mandate Azure Key Vault for secret management. Another NFR is a strict budget concern. You must prioritize the serverless technology like Azure Function and use reserved instance or Azure Hybrid benefit for stable compute workloads. To optimize the cost, to control the cost in a cloud budget, we need to we must prioritize the serverless function or reserved instances to optimize the cost. So these are all the reliability, availability, performance, scalability, security, cost. These are all the non-functional requirements we need to consider during the architecting a cloud solution. Here, the crucial takeaway is we could satisfy every single functional requirement, like design the app, design the e-commerce portal. We can design the login page. We can design the product page. We can implement the logic, business logic. We can do it. See, we can satisfy every single functional requirement, but if the system fails to meet the non-functional requirement, if the web app keep crossing every week or takes 30 seconds to load, if there is any data breach, data leakage in the apps, then the project become unmitigable failure, unmitigated failures. So we should satisfy functional and non-functional requirement to create a stable, viable cloud solution. Let us take a look at trade-offs and conflicting NFRs. When we are satisfying one NFR, you often incur a negative impact on another. When we are trying to implement one NFR, it will create a negative impact on another NFR or another FR. So the architect job is to navigate these trade-offs to find a optimum solution that meet the business prioritized need. Let us take this performance with cost optimization. During the cloud infrastructure designing, it is the most common conflict. Achieving a better performance almost always requires more expensive resources. So NFR priority, non-functional recommended priority is high performance. If you go for high performance, if it is critical systems, critical project, critical environment, we should use premium tier for Azure App Service. We can use Azure Cosmos DB or large Azure VMs, high-end VMs. So it will provide a high performance like 99% latency, less than the latency must be less than 50 milliseconds. If you look at the trade-off, the cost part, it will increase the cost. The premium and reserved capacity sources cost significantly more than the basic tiers or services option. So if you go for the performance, high performance, we need to trade off the cost. If you go for the high cost optimization, budget should be like $5,500 per month. If there is a budget limit, we should go for Azure function or basic tier app service or smaller VMs. If you use this basic tier web app or smaller VMs, it will affect the performance. It will leads to decreased performance. So consumption plans have cold start and smaller VM cannot handle the high transaction volume effectively. So there is always a trade-off and conflict in implementing NFRs. The another trade-off is security and usability. Strict security measures are essential, but they often add steps, complexity, and latency to the user experience or operational management. If you implement strict security policies, that will lead to complexity and latency for the user experience or operational management. If the NFR priority is high security, that is like implementing the zero trust framework for all the digital assets, user accounts, data, apps, user devices, cloud infrastructure, everything. If you want to implement zero trust framework for all the digital assets, so for that we have to enable the multi-factor authentication for all the users, and we have to it will require a service to service communication via Azure Private Link. So these are the some of the factors to implement the zero trust framework to secure the cloud workloads. The trade-off is the impact is decreased usability. So MFA will add on extra steps to login, increased complexity cost. Setting up private links and VNet peering adds management overhead and network complexity. So there is always a trade-off between NFRs. If you go for high usability like single sign-on, we can allow a simplified login via Azure AD SSO only. Here the trade-off is decreased security. Rely solely on a single credential. If compromise, the entire system is at risk without a second factor. So these are all the trade-offs when we are implementing the NFRs. The another one is reliability with complexity and maintainability. To maximize the reliability, we often introduce redundancy and complexity across multiple regions. If the NFR priority is high reliability, like ARPO is less than 5 seconds. For that, for the high reliability, we need to deploy the solution across multiple Azure regions, like active setup. And we have to use the Azure Traffic Manager and the cross-region database replication. If you want the high reliability, we have to implement this solution. Multiple Azure region, Azure Traffic Manager and cross-region database replication. Here the trade-off is the complexity is increased complexity and the maintainability because we are spreading the solution through multiple region, US, Europe, Asia region, and we are distributing the traffic through using Azure Traffic Manager. So this one it will increase the complexity and maintainability. Managing, monitoring, and debugging a distributed system across two regions is exponentially more complex than a single region deployment. So if you want to go for high maintainability, see like simple operation, deploy a single Azure region and use a availability zone only. Here the trade-off is decreased reliability. Still vulnerable to a full region outage. RTO RP will be declared by the region's disaster recovery capability, which are typically slower than the active. So there is always a trade-off between non-functional requirements. The another one is scalability with cost optimization. Designing a system to handle massive, unpredictable peaks usually means paying for unused capacity during the quiet times. If the NFR priority is high scalability, handling unpredictable load spikes, we can go for VM scale set with high baseline count or utilizing highly elastic but cost intensive services like Azure Cosmos DB. Here the trade-off is increased cost. We pay for the provisioned baseline capacity even when demand is low. If you go for high cost optimization, You can use auto scaling minimum of 0. Only rely on cheaper and slower to scale tiers. So decreased scalability. The system must suffer temporary performance degradation during sudden spike due to its life need to be spin up. So as a ASUS solution architect, our job is not to just select the ASUS services, but we have to prioritize the non-functional requirement based on the business input and strategically select services that provide the best balance of these quality attributes. So we have to take care of scalability, reliability, availability, security, compliance. All these factors when we are designing a solution for cloud infrastructures, need to take care of all these non-functional requirement. Let us take a real world example, a global e-commerce platform. The business goal is a major retailer is launching a new global e-commerce platform like Flipkart or Amazon. They are going to launch a new global e-platform on Azure to handle the peak holiday shopping traffic and process millions of transactions per day or 24 by 7. So if you look at reliability, availability NFRs, the measurable NFRs are SLA. Ignore the dollar symbol here this. So SLA is 99.99. Uptime. This less than 5 minutes downtime. So our choices we can go for Azure App Service Premium tier or we can go for Azure Kubernetes Service. Node spanning 3 available zone in a primary region. So architectural decision. This decision ensure application redundancy across physically separated data center within the region. If you want our RPO and RTO less than 5 minutes, we should go for database, Azure SQL database, hyperscale or Azure Cosmos DB with continuous backup and geo redundancy to a secondary region. So the architectural design, low RPO requires continuous or near real-time replication. The RTO drives the need for automated warm standby setup. If you look at the performance and the scalability NFRs, if you want our system, if you want our solution, latency, the page load time is less than 1 second globally. We have to choose the Azure services like caching and edge. We can deploy Azure front door with Azure CDN enabled, and we can deploy the Azure cache for Redis for session state and popular product. So caching at the edge, CDN and in-memory reduce the load on the backend and dramatically improve the response time for the static and frequently accessed dynamic content. Scalability. If the non-functional requirement is the system or the e-commerce platform must handle a 5 times surge in traffic, that is Black Friday sales automatically, we should deploy the e-commerce platform in Azure Kubernetes service with horizontal or pod autoscaler. HPA allow the system to automatically add more compute instance based on CPU memory usage or custom metric like queue depth, meeting surge without manual intervention. Security and compliance NFR. If you look at the security and compliance NFR, if you want to implement the compliance standard like PCI DSS, then we should go for WAF, Web Application Firewall, Azure Application Gateway or Azure Front Door with web application firewall enabled. We can go for Azure Private Links for the database connections. So the architectural decision is PCI DSS require specific security control, WAF protect against common web exploits, and a private link ensure all the backend database traffic remains on the secure mix of backbone network. Secret management. All connection strings and keys must be securely stored. So we can implement the Azure Key Vault. So the architectural design is centralize and secure the secrets, ensuring no sensitive data is committed to source control or stored directly in the application configuration files. So these are all the security and non-compliance, security and compliance NFRs. We should consider when designing a cloud infrastructures, compliance, security management, latency, scalability. These are all the factors. These are all the NFRs we must consider during designing the cloud infrastructures. Cost optimization NFRs. For example, if the cost target is keep the 70% of the compute cost predictable while maintaining high scalability, for this requirement we should go for compute reservation. Purchase the Azure Reserved Virtual Machine Instances RIs. So that will reduce the cost by almost 75%. So the architectural design is RI offer a significant discount up to 72% discount we will get compared to pay as you go. For the serverless for background, we can use low cost event driven pattern of non-critical tasks. Like we can go for Azure function, we can go for Azure service bus or event bus, Azure event hubs for order processing and inventory updates. So this will utilize a serverless pay per execution model for asynchronous tasks, which is cheaper and highly scalable than keeping dedicated VMs running for them. So when we are designing the cloud infrastructure, the Azure architecture is a direct result of measurable non-functional requirement defined by the business. Let us look into the architectural trade-off. In the context of designing a Azure solution, the trade-off is the act of give up one desirable quality or feature to achieve a greater level of another quality or features. This architectural trade-off is the architectural design is fundamentally the management of trade-off. So when you rarely have the budget, time or technology to maximize every non-functional requirement simultaneously, maximizing one quantity attribute, one quality attribute like reliability almost always necessitate the reducing the performance in another area like cost, simplicity or sometimes performance as well. So there is always a trade-off when selecting the non-functional requirement. If you want the cost, if you want to cut the cost, if you want to optimize the cost, the trade-off is performance. The trade-off is scalability. The trade-off is security. The trade-off is latency. So we must consider all these trade-offs in non-functional requirement. Let us look into the critical Azure trade-offs. As a Azure architect, we must able to recognize this conflict, discuss them with the stakeholders, and document the chosen compromise. So when we are as a solution architect, we need to interact with the stakeholders, we need to interact with the clients, we need to interact with the delivery managers, project managers. We need to discuss all these trade-offs, all these non-functional requirements. we should make a document it. If you look at the trade-off, cost optimization and reliability performance, if you want to maximize the reliability, if you want 99.99 SLA, the sacrifice is the trade-off is cost optimization. To achieve 99.9 SLA, you must deploy across multiple Azure regions like active setup. That means you are doubling your capacity, compute, network, and database. Like we have a high availability infrastructures. We should have a primary region. We should have a secondary region. If the primary goes down, it will automatically become up the secondary region. So it is a reliability. So it will increase the cost. So if you want to maximize the cost optimization, here the sacrifice is performance. So to optimize the cost, you will go for serverless function, consumption plan, minimize the cost. So the trade-off, you accept the potential cold start, latency, sacrifice in the performance when the function is invoked for the first time after a period of inactivity. So we must consider all these trade-offs in cost optimization and reliability and performance. If you look at the security, usability and performance, security measures are often inconvenient or introduce processing overhead. If you want to implement the maximize the security, if you want to implement zero trust framework for a product all your digital asset, the sacrifice is usability and management overhead. If you implement lot of security policies, the users will get affected. Deploying a database with Azure Private Link ensure network isolation and security as traffic never leaves the Azure backbone. The trade-off is developer can no longer simply connect to the database over the internet for troubleshooting or recurring jump boxes or VPN, adding complexity to the operation. So there is always a trade-off. We are implementing the full-fledged security. There is always trade-off for usability and management overhead. If you want to improve the maximize the usability, here the sacrifice is security. So allowing user to access resources using simple password only authentication, the trade-off is increased risk of unauthorized access and credential theft. If you look at the scalability, simplicity and manageability, the system designed for extreme scale are inherently more complex to build and maintain. If you want scalability, you can go for microservice architecture. Here the sacrifice is simplicity and maintainability. Moving from a single Azure app service monolithic to Azure Kubernetes service, microservices architecture, the hundreds of containers, the trade-off is you gain a massive horizontal scaling power, but the management, networking, monitoring, and debugging of AKS are more complex than the simple app service. So if you want to implement the maximizing simplicity, the sacrifice is scalability. If you go for a simple architecture, simple deployment using a single vertical scaling Azure VM monolithic, the trade-off is when the VM hit a CPU limit, you can only scale up to a next size. Consistency and availability. CAP theorem. While not strictly on NFR, there is a most famous computer science trade-off that directly impact your database chosen in Azure. The CAP theorem states that a distributed data store can only guarantee two of the three properties: consistency, availability, and partition tolerance. In a distributed system like Azure, the partition tolerance is generally mandatory, leaving you with a choice between consistency and availability. So if you want to improve the consistency, the trade-off is availability. For example, we can deploy the Azure SQL database. This system ensures all readers see the most recent computed data. The trade-off is the network issue prevent immediate synchronization between replicas, the system must refuse the read and write operation until the sync is restored, so thus sacrificing the availability during the window. If you want to maximize the availability, here the sacrifice is consistency. Like if you are deploying the Azure Cosmos DB using a eventual or session consistent level, the system is available to read and write data, always available to read and write data. But the trade-off is a read operation might temporarily retrieve slightly older data from the replica from the it has fully synced. So as an architect, we must prioritize the all these NFRs, which is the business leader, which is the respective stakeholders, to design a efficient cloud solution. If the business says reliability is paramount and the budget is secondary, then we can go for expensive multi-region reliable solution. If the business says cost is the biggest constraint and the minor downtime is acceptable, then you should lean forward to the cheaper, simpler, but less resilient solutions. So, as a solution architect, whenever you deploy a solution, when you are developing, designing a solution for cloud infrastructures, we should prioritize the NFS, connect with the business stakeholders, clients, delivery managers, account managers, project managers, discuss all the NFS, prioritize them, and implement a efficient and consistent solution. Thank you. We will connect in another video.